Okay, start with number 5. What is the least common denominator for number 5? 18. Great job. Okay, so I'm going to put least common denominator equals 18. And then I'm going to say times 18 times 18 times 18. 18 times 6 is 108. 18 times 19 is 342. 18 times 85, 1,530 over 18. Okay, now I'm going to divide, and it's the moment of truth. So if I did it correctly, they should come out whole numbers. Great. Okay, these two are like terms, so I'm going to combine them. 108 minus 57. Okay, here's my question. Does anything divide into 85 and 51? 17. You guys are like, woo. Okay, now to be honest with you, if I was doing this problem just sitting by myself, I wouldn't have done it this way. I would have said 85 divided by 51, and then I would have said, hit the math button, and then told the calculator to change that to a fraction, and it would reduce it for me. You guys all have the capability of doing that on your calculator somewhere. If you need help figuring out your particular calculator, I can help you, but that's how I would have done it. Okay, now moving down to number 7. This one has I think, a more difficult least common denominator. I really wanted to say 35, but it's not 35. Yeah, I don't think 3 goes into 70. I think it's 105. I actually, there might be something better than 105, but I know 105 will work. It might not be the least common denominator, but I know that it will work. Do you guys know where I got 105 from? Does anybody know, like, my thought process in my head to where I got 105? Okay, so what I did was I said, okay, I know 7 goes into 35 evenly. So the common denominator between those two is 35. But 3 does not go into 35, so I just multiplied those two because I was like, that's the best I can do. Okay, so times 105 times 105. Don't forget to times 105 on K. It's a really common mistake. Okay, so I multiplied everything by 105. Now I'm going to divide. I actually know what this one is. I shouldn't have done it on the calculator, but that's okay. Oh no. Okay, now we should not need a calculator for this one. What goes into 21 and 35? Yeah, 7. Beautiful. Awesome job. -3. Hey, our answers from 5 and 7 are opposite reciprocals. Okay, you guys, I think we're done with the packet for the moment. You can scooch that to this side. I want to think back to the golf balls from yesterday. This has to do with the golf balls from yesterday. However, it's a little bit different. You guys notice what the X value is in this table? It's bounce number. And it's not gonna look good because it's a carpet, but it's thinking about what would happen if I let it keep bouncing. So picture yourselves out there with your video, right? And you dropped it, and we're just gonna pretend we're doing the 201, which is tall. And you drop it, and it comes back, and you drop it, and it comes back, and you drop it, and it comes back, but it's never gonna go as high as it went before. Does that make sense? So it's gonna get shorter every time. It's gonna get shorter every time in the same ratio that it bounced the first time. Is it okay with you guys for this problem if we all go with 0.7? Because we are all right around 0.7, but let's just all use the same number in this so that we can all have the same math. Okay, so what I'm saying is that if my falls rebound ratio was 0.7, then my pen would be right here. Okay. Then the height at the first bounce would be 200 times 0.7. Okay. And what is 200 times 0.7? Well, what's 2 times 7? 14. So 140. Okay. So what I'm saying is if I dropped it from 200, so put a dot up here. I'm dropping it from 200. And after bounce 1, it would come back up to 140. So I want you to kind of picture the ball. It dropped, came back to 140. Does this make sense? Okay. Now what I want you to do is take your calculator and keep multiplying by 0.7. Fill in the rest of the table. So 140 times 0.7 times 0.7 times 0.7 times 0.7. So theoretically speaking, if there was no wind and it didn't hit a rock or something weird, or hit that weird plate that's along the wall on the other side, go flying off, it should come back up to these heights. So 98's right about there. 68.6. What shape did this end up making? It's a curve, right? And it should remind you of the bunnies problem. You remember how the bunnies problem, we had 3 different curves? Okay, why is it going down though instead of up? Because we're multiplying by a decimal. Yeah. Since we're multiplying by a decimal, this is called exponential decay, meaning that it's getting smaller and smaller each time by a curve. Okay. This has an equation. So I'm going to remind you of the equation. We worked on this on the bunny problem. It's y equals the start times the multiplier to the x. So start times the multiplier to the x. Okay. Now set up 3 bullet points for number 32, and we're going to write 3 different facts about exponentials. Okay. Okay. First thing you need to know. Exponential functions are created by repeated multiplication of the same number. Really? Hold on. Let me. Um, okay. So it could be a whole number, it could be a decimal. But what makes these different from a line is you're not adding the same number every time, you're multiplying the same number every time. Okay, next thing you need to know, exponential functions make a curve. Not a line, it's a curve. And the last thing is that the equation is y equals ab to the x, where a is the start and b is the multiplier. Don't look at the rest of this page. That is not for today. Okay, now what I want you guys to do is grab your foldable, and I want you to do 2 things. I want you to find a spot in your notebook that's like a blank page. I want you to, okay, so this is what I'm gonna do. Hold on, let me do it underneath the thing. So what you're supposed to do is cut out on the dashed lines. So everywhere there's a dashed line, you cut it. So like cut this square or this rectangle out here. And then just cut these strips. And then what you're gonna end up doing is putting glue stick on this back part and glue sticking it in somewhere where you have a blank page. I'm gonna tape mine because I just can't do glue stick. Okay, then fold the little doors in when you get it glued down. Go ahead and recycle the two little extra green pieces. Okay, so this guy, once you got him situated, is meant to help you decide between linears and exponentials. We spent our whole year on linear so far until the last week. Just this last week, we've started to work on exponential. So all of this stuff is really familiar, I hope. And the exponential stuff is new. Okay, first let's look at the linear side. If you open the linear side, this is the slope. This is the y-intercept. Okay, now we're gonna fill in the table we're gonna start with this box. What number goes here in my table? 2. Great. Okay, and then what I want you guys to do is put your little Amazon arrow underneath and show that growth of +3 each time. So this would be 5, 8, 11, -1. Okay, any questions about the table? Okay, real world situation. Your savings account starts with, okay, what was the start? $2. Every week you deposit $3 into your account. Okay, and then at the bottom, we're going to graph it. You can graph the points off of the table or you can graph the equation. So y-intercept of 2, slope of 3, so up 3/1 each time. Don't forget to backtrack. This is pretty much what we've done since August. This whole deal, actually, maybe not August. Did we start it in August? We did? Okay, probably. Okay, so linear side is done. When you're done with that, you can close it up. Okay, so this is where we're going. So exponential. This is the y-intercept or the start, and this is the multiplier. Okay. Now this time the y-intercept is 3. My start is 3. And make your Amazon arrow and put ×2. So this would be 6, 12, 24. And working backwards would be 1.5. Does that make sense, guys? You see where the things went? Okay. Real world situation. Your savings account starts with $3. Every week, the amount in your account doubles. And this number might change depending on what your multiplier is. This particular one is doubling. Man, I wish every week the amount in my account would double. That would be awesome. I'm the kind of person who, like, if I have $1, though, I have to spend it. I don't know what's wrong with me. Like, the rest of my family is good at saving money. I am not. I'm terrible. It's why I have so many Squishmallows. They should have my picture next to the cashier, like at Five Below. Just be like, no, this lady's not allowed to buy any more Squishmallow. But, you know, I still go. They still let me buy them. Okay, last bit. So we're going to do our graph. So -1, 1.5, 0, 3, 1, 6, 2, 12. I can't go any further than that. What I want you guys to do though is follow the curve pattern like that. Okay, now real quick, I'm pretty much done, but I have some really, really nasty people in the room. And I want you guys to notice that I flattened out right here. And I try really hard not to touch the x-axis with my curve. Okay, and I did that on purpose. So I want you to think about what would happen if I kept this table going backwards. So look at the 1.5. What would be right in front of that? 0.75. What would be right in front of that? Just go on your calculator for me. Do 0.75 divided by 2. Because you're going backwards in the table, so you're dividing by 2. What's 0.4? Okay, now divide that by 2. 0.375 divided by 2. Divided by 2. Divided by 2. Divided by 2. Am I ever hitting 0 is my question. No, my decimal is getting smaller and smaller and smaller, but it's never going to be 0. This is actually called a mathing, but for now, just notice that I just want to flatten out on the x-axis. I'm just going to leave you hanging with that now. Okay, can you guys please look at your stamp sheet? Okay. What do I need to stamp? This and this, correct? Okay, and then homework is 35 to 40, skip 38, which I'd like you to work on right now, please.